All right, there we go. So we left off on page 37 here. This is what we're going to be graphing. All right. So if we look back, okay, at our official formula of how we handle things, this is the amplitude that controls the height of the whole thing, but especially the height between the middle and the top and the middle and the bottom. Okay. This is the trig function. It's either going to be cosine or sine right now. Remember, this guy deals with B, with the period. If you have parentheses, you can't put them in, but if you see them, you have a phase shift. You have a horizontal shift. Joy, put your phone down. If you have something added on the back, you have a vertical shift, right? Okay, so the reason I want to do this one here and then compare it to the next one is that some students see this, they see they have an amplitude. Okay, so we're, instead of having one unit between the top and the middle and the middle and the bottom, you're going to have 3 units between each. So you're going to have a total of 6 between the top and the bottom. Okay, we have cosine, right? So we're a cup, we're dum. We're up, middle, down, middle, we're a cup. Here's our B. It's a 2. Okay, I know that's my B because he's just there in front of X. Here's where students get confused. They don't know if this 2 means that he's been shifted horizontally or if he's been shifted vertically. But remember, he's only horizontal if you see parentheses, and there aren't any. So there's no horizontal shift. There's just a vertical shift. That's it. Just a vertical shift. Does that make sense? Okay, so let's just jump right in. We'll do a quick little graph of him. Let's answer some questions first. So amplitude, okay, absolute value of that guy, which happens to be 3. All right, then we want the period, which is 2 pi over B. Our B is 2. So our period's actually just going to be pi. He's going to be squished in. We need the whole cup, the whole dum in pi instead of 2 pi. All right. Then our jump, remember those are our points that we're going to draw our graph on, is the period divided by 4. Well, our period's pi, so our jump's pi over 4. Okay, vertical shift, that's who's out here. It's a +2, so we're going to go up 2. And we have no parentheses, so there is no phase shift. Okay, and there we go. Now, I'm going to also do a starting point for this guy, just so you can see where the cup is supposed to start. But to be honest with you, I normally don't. I just figure it out according to those clues. And I don't really ever do any algebra when I graph. I just use that info. But I know a lot of you, if you came from pre-calc or if you're in pre-calc, Mr. Alfred does it the complete opposite way. You have to find every point first. Once you find your points and do your algebra, then you make your graph. So it's kind of just 2 different approaches. I'm lazy, so, I think this is easier. Okay, so if we were going to do a starting point, okay, let's just go ahead and look. What we would do is take this portion here. You would take the parenthesis portion, actually, but since we don't have it, we just take the X portion and set it equal to 0. And we solve for X. Okay, so we solve for X. X is 0. Awesome. So our starting point is going to be the point 0 something. That's our X coordinate. Then we put that 0 back into this whole thing and solve for Y. So I'm going to have Y equals 3 times the cosine of 2 times 0. But 2 times 0 is 0 plus 2. Okay, so now I need the cosine of 0. Well, here's my unit circle. Here's 0. Cosine is 1. Does that make sense? I just looked at right off my unit circle. Okay, so he's a 1. So what I really have is 3 times 1 plus 2, right? Because the cosine of 0 is 1. So that's going to give me 5. So my starting point, where I start up for my dum, for my cup, is going to be 0, 5. Okay, but I'm going to also show you, you don't really have to do that. You can figure it out based on the info we already have. Okay, here we go. So I'm going to make this guy my y. You can make anybody your y you want. Okay, there we go. Let's see, I'm going to do this my x. Here we go. Okay. All right. Now I need to put some tick marks in, right? Some little marks on my x-axis. How do I know what they're going to be? My jump's pi over 4. Those are going to be my tick marks. So I'm going to kind of spread this out so we can see it a lot. So I'm going to call this one way over here pi over 4. You can make it closer if you want. Okay, that's 1 pi over 4. This is going to be 2 pi over 4. That's actually pi over 2. This guy's going to be 3 pi over 4. Okay. Next one will be 4 pi over 4. That's just pi. Okay. I'm going to keep going just a little bit longer. That's 5 pi over 4. Okay. And then I don't know, I could go one more if I wanted. 6 pi over 4 is actually 3 pi over 2. I'm just going to go out a little bit. So that's where the tick marks come from. They're just your jumps, right? Okay. So the other thing we know about cosine is right here. We're dum, right? Up, middle, down, middle. There we go. Okay. So normally I would start up, go middle, down, middle, up. All right. Here's the thing though. I have an amplitude of 3 and a vertical shift of 2. So let's think about this. I want to put in where my upper level would be, the middle level would be, and the bottom level would be, right? Okay, so normally, so let's go ahead and put some tick marks on the x-axis. Let's just say this is 1, maybe this is 2, this is 3, maybe this is 4, okay, maybe this top guy is 5, I don't know, okay. Help if I was on the right page. Okay. And then I'll go down here with -1, -2, -3, -4. Okay, there we go. Okay. All right, so I'm not shifting either way to the left or the right. Everybody agree with that? So I'm starting on the y-axis with my up. Everybody, right? Because I'm not moving left or right. I'm starting somewhere on up. Okay, normally I would be starting right here at 1. That would be up. But I have a vertical shift of 2. So instead of starting at 1, what do I need to scoot up and do? Good. Well, I guess I should actually, let me say here. Let's go to the middle. I'm sorry. Let me start over. So the middle, think of the middle would be the x-axis, right? Okay. I know that normally you'd start up, middle, down, middle. Okay. But so this should be the middle, right? Would be right here. But I've been shifted up 2 because of my vertical shift. So where's my middle going to be now? This is going to be my middle. It's going to be at 2. This is now my middle. Okay. All right. So if this is now my middle, I have to go up even further to find the up. I have to go up the amplitude to find the up. And my amplitude is 3. 1, 2, 3. This is actually going to be my up, or my top is way up there, because this needs to be 3. Okay. Then if I go back to my middle, where's my down going to be? How many am I going to scoot down for the down? 3 for amplitude. 1, 2, 3. My down is going to be right here. Because again, this is 3. Okay. So remember, your amplitude is the distance between your middle and your up and your middle and your down. So if here's my middle and I have been moved up 2 vertically, there's my middle, then my amplitude sits on top of that to give me up, and my amplitude sits below that to give me down. Everybody got that? So that's kind of where we are. Okay, so Here's my up, here's my middle, here's my down. Now I'm ready to just jump right in, okay? So I would be up, middle, down, middle, up. And then if I wanted to keep going, that's a whole period and it ended at pi. I could keep going if I wanted to. You don't have to. Then you kind of connect it. Remember, we don't want shark's teeth. You got to put a little curve in it. There we go. There's your cosine. Okay. Now, if we wanted to go by points, where did it tell me to start? 0, 5. Did we start at 0, 5? We did, but we figured it out just from the movement. And so you can kind of do it either way. You'll never have to give me a starting point, but if that helps you, you can use that. So I find the middle where I would normally be, which is always the x-axis. Then I figure out my vertical shift. In this case, I went up 2. Then I add the amplitude to it. I subtract the amplitude from it. And then I have an up, a middle, and a down, right? With the amplitude dividing them. I didn't have any kind of horizontal shift. And then I just put my points and I have my graph. Does that kind of make sense a little bit? Okay. All right, let's try another one. Is everybody okay if I turn the page? Good. Okay, so notice on this guy, there were no parentheses. So we did not move horizontally. Okay. No horizontal movement. Let's look at this guy. Are we going to have horizontal movement? We are. Do we have vertical movement? No, because we don't have anybody added to the end. Excellent. Okay, we're actually going to not graph this one. This one's already on there for you. We're going to graph another one that has more happening, but let's just make sure we would know what to do, okay, because of time. All right, we still have that amplitude of 3, right? So we better have 3 vertical tick marks between middle and up and middle and down. We have sine this time. Our b is 2, so 2 pi divided by 2, periods pi. All right, and we have a phase shift of -4/pi. So where's that -4/pi? Is it shifting us left or right? The opposite of what you think. Remember, for x, shifting you right, shifting you right. Okay, good. Okay, so you can take a look at this on Blackboard if you want to. This is what your graph ends up being. Here's your starting point right here because you were moved pi/4 to the right. So there's your little sine curve. There's up, there's down. Go ahead. Well, you can't, I always kind of like to start at the y-axis to kind of scoot over. But if you start here, then you know you're just going to go down, you know. Okay, let's look at one that has all kinds of weird stuff happening, and then we'll go from there. Because here's what I really want to get to. This is the important part, is number 39. We learned about even and odd functions, right? We have to figure out how that impacts graphing, because that's a pretty big deal. So remember, cosine and his reciprocal secant, those are even. Doesn't matter if they're positive or negative theta values. Everybody else is odd. So what does that mean for graphing? Okay, so, well, first of all, I jumped ahead of the game. Okay, let's look at this. If you have a negative out front, then it's the next page that talks about what I'm talking about. I'm trying to get all this in. I'm worried about your time. Okay, so here we go. Forget what I said about even and odd. We'll do it on the next page. We have something happening here we haven't had before. We have a negative out front. We haven't had that. Okay, so remember, a negative out front is a reflection over the x-axis. That's all it is. It doesn't really affect anything else except you're reflecting. Okay, every time there's supposed to be a mountain, you're going to have a dip or valley. Every time you're supposed to have the dip or the valley, you have the mountain, right? So that's all we're going to do is kind of flip that. All right, so amplitude is still always a positive number. In this case, it's just 2. It doesn't matter. That negative only affects the reflection, not the amplitude. Okay, we don't have a phase shift because I don't see parentheses. We don't have a vertical shift because nothing's added or subtracted in the back. Okay, my b is 3. So my period's going to be 2 pi over 3. It's kind of messy. I can't do anything with that. I can't reduce it. So that's the whole sine curve has to fit in 2 pi over 3. Okay, remember your jump is the period divided by 4. Okay, now we have a little bit of messy algebra because we have 2 pi over 3 divided by 4. We're not going to be scared because we're going to keep, change, flip, and then it's not bad. Okay, we're going to keep, we're going to change, and instead of having 4, what are we going to flip it into? 1/4. That's just 2 pi over 12, or reduced, that's just pi over 6. That's a nice little jump. That's not scary. Okay. All right, we don't have vertical shift. We don't have a phase shift. If you wanted a starting point, you're going to take 3x equal to 0, solve for x, you get a 0. You're going to plug that back in the whole thing, see what you come up with. I'll go ahead and tell you that what you come up with there is actually going to be the origin, 0, 0, when you plug that all back in. You don't have to find a starting point, but some of you like it. So there it is. Okay. Then here's the, oh, go ahead. I'm sorry.
Can you graph these on the calculator?
You can. And that's another thing I wanted to show you, but if we don't get to it today, I'll show you on Wednesday. I know. Okay. The one day for the bus driver to have a bad day. All right. So normally sine is MUMD, right? Middle up, middle down. Okay, but we've been reflected. So if normally we look like this, the reflection of this is going to be, instead of, I start at the middle because the middle is the middle, whether you're upside down or not, right? Still the middle stay. Instead of going up, I'm going to go down, back to the middle because the middle is the middle. Instead of going down, I'm going to go up, back to the middle. So our middles didn't change. Everywhere we had a middle, the middle stayed. But where I had an up, I made it a down. Where I had a down, I made it an up. So instead of MUMD, I'm MDMU. Okay, I don't have anything cute to say for that, but that's what that is. Mudmoo, I don't know. So that's what he is. Okay. Here we go. We're going to do our y. We're going to do our x. Okay. I'm going to put in jumps 1 pi over 6. Here's 2 pi over 6. That's pi over 3. 3 pi over 6. That's pi over 2. Everyone has a different denominator. Here's 4 pi over 6. 2 pi over 3. That's good enough. That'll get us one. That'll get us one period, as it should. When you're done putting in 4 tick marks, that 4th tick mark better equal your period, right? It better equal your period. Better be the same thing. All right, here we go. We're not moving up or down or sideways. Okay, let's put in some, a 1 and a -1. Okay. So here's our middle, right on the x-axis. Okay. Since we do have an amplitude of 2, we're going to have to stretch out a little bit. There we go. From the middle, I go up 2. Okay. This is my up. I go down 2. That's my down. Okay. Here's my amplitude of 2 right there. That kind of gives me my layers there. Everybody got their little layers there? You got your jump marks. You're ready to go. Okay, so we're still going to start at the middle, but we're not going to go up. We're going to go down. We're going to go back to the middle. We're going to go up. We're going to go back to the middle. And then we're going to connect it. And there we go. And we're all set. Okay, and if you wanted to keep going, you certainly could. Scoot that up a little bit. Okay, is that better? Everybody okay with that? And then if you needed to give points, depending on what class you're in, okay, this point is 0, 0, right where we said we should start. This point is pi over 6, -2. This point is pi over 3, 0. This point is pi over 2, 2. You can still list all the points, but you didn't have to find every set of points algebraically. Okay, does that make sense? All right, you guys are quiet. You're good with this? Yes, kind of? Okay. All right. Now let's talk about even and odd situation. And then I'll show you how to do some stuff on my math lab. Okay. All right, so let's talk about this a minute. We don't have to go through this whole thing, but let's just do the quick and dirty thing here. Okay, so we've had every possible scenario so far except 2, really. Okay, we're gonna handle both of them right now. One is you have parentheses, but you don't have a b out front. You have a coefficient for x. That's not cool. You can't say, oh, great, my b's -2, and I'm going pi to the left. That's not true, okay? We have to fix this. We have to pull out a -2 because the coefficient for x has to be 1, especially important when you have parentheses. We haven't had to do that before. Other issue is our b's negative. That's not cool, okay? We have to figure out what to do with him. All right, so first thing we're going to do is pull that out. So I'm just going to kind of come down here and write it over. Okay. 3 sine. All right. Since he is negative, I like to put him in parentheses because I don't want you to think you're subtracting 2. All right. If I divide a -2 out of both of these terms, I get x minus pi over 2. Everybody okay with that? Then it's a completely different problem. Not only am I going to need to deal with the -b, which by the way is going to show us it's a reflection in just a second. So we're not even going up, down. Now look at my phase shift. I thought I was going pi to the left. Where am I actually going? Pi over 2 to the right. It's like a totally different graph. That's why it's so very important. Your coefficient of x is 1 when you have parentheses. Please, please, please check that and pull that out. That's extremely important. Okay, now what does this even odd thing have to do with it? So remember, for the even guys, if your angle here is negative, it's no big deal. You can just forget it exists and make it a positive for cosine or its reciprocal. For everybody else, you need to take that negative out. For example, this negative right here, and do what with it? Move it to the front. This negative comes to the front. You need to rewrite it like this. This is actually what you're graphing when all is said and done, is this guy, okay? Huge difference from the one that we started with. So we're going to have a reflection and we're going to have a phase shift that's different and in a different direction than what we originally thought. All right. And that's because sine is odd. That's because sine is odd. We're going to look at what would happen if that were negative. Okay. So before we get into any more with this, what if we had, all I'm doing is changing it like this. All I did was I took this one up here where we had pulled out the -2 and I put cosine in its place because cosine's even, right? What if I had this? If this is what you have, you just change it right onto this. And this is what you would graph. There would be no reflection. This is where students get confused, okay? We're gonna go into this a little bit deeper in just a second. It's because cosine is even. We just get rid of it. Now, you still have to pull it out of the phase shift because it's going to affect your phase shift, but you don't move it to the front, okay? You leave it just like that for a cosine. Is that okay? Okay, let's look at it a little bit further. Let's turn the page for a minute. We're going to come back, but let's just, some students like to get all this out at once. So let's just turn the page. Okay, let's look right here at the bottom. All right. because I see some of your brains going. Okay. So since cosine is an even function, this equals this. They graph exactly the same. The negative b only matters when there's a phase shift because you have to pull it out of the parentheses. You have to divide out the negative b to get a correct phase shift, but the graph does not flip, okay? So when is a cosine ever gonna flip? Can't a cosine flip? Sure it can, if it starts out with a negative in the front. You can't ever place a negative in the front of a cosine. But if it starts out that way, you're going to flip it. So both of these are going to be flipped over the x-axis, okay? Because it started out with a negative. If it starts out with a negative anywhere else, you can't move it to the front. It has to just be there from the get-go to have a reflection. Sine, no matter where that negative is, you're going to put it in the front and flip it. He's different, and that's because he's odd and cosine's even. Does that make sense? Okay, so that's one of those things I don't know is ever really thoroughly explained, so I just kind of want to go through that again. Okay, so what we did then, I think this is the same thing. Okay, let's look at this then. This is the same thing we just did, right? We just moved the negative to the front, and we have this. So one of my math lab questions is going to be, I don't see it now, but it's going to be write the equivalent form of this guy when you would go to graph. And the equivalent form is just that you move the negative out front, right? That's it. They're the same thing when you go to graph. Okay, so let's just talk about this really briefly because again, we're kind of out of time. Here's the graph. This is what it's going to look like. Let's talk about why it looks like this. All right. So when it comes down to it, I don't have a vertical shift. So my middle stays my x-axis. My amplitude is a 3. So here's a 3 up, and here's a 3 down. Okay, that gives me my up and my down. All right. My period is going to be 2 pi over 2. So the whole thing has to fit into pi. And then pi over 4 is going to be every tick mark. Those are my jumps. All right, here's where the starting point gets shifted. My starting point is not going to be 0, 0. My starting point is going to be, okay, pi over 2 to the right. So instead of starting here, because some students will look at this and go, oh, you forgot to flip it, Ms. Holcomb, because you went up, down. And remember, it's supposed to be flipped and go down, up. You're right, but I didn't start here. Where did I start? Over here. I went pi over 2 to the right because of the phase shift. My starting point is here. And I went down, up, back, right? And so then when I just continued the pattern, it looks like I forgot to shift it, but I didn't. Here's the starting point over here. Okay, so it can be a little confusing. Does that make sense? Okay, so, all right. And then example 10 again, just wanted you to rewrite it. So I did right down here where I pulled the negative out front so that you can see it there. Okay. I hate that I'm having to rush through this, but my notes are on there. I think you guys have got it. It's just a lot of the same thing. But if you don't, you let me know. Okay. Kind of want to see what's coming next. Are you guys okay with this if I pick it up? Good? Okay. You want to take a picture? Everybody good? Okay. All right. Okay, so then there's just one more. Just one more. I don't think there's really anything to talk about here except that I had a coefficient of x, so what did I have to do? Pull it out front. And when I divide both of these terms by a 3, pi over 2 divided by 3 is actually pi over 6. So again, my starting point is not up here for my cup, for my cosine with an amplitude of 2. My starting point is here. So he looks just like a sine graph, but that's because I had to start pi over 6 to the right. That's what I did to get my graph. Okay, so here's my up, it's at 2, my down's at -2, and that's how I ended up with that guy. Okay, is everybody okay with that? Okay, all right, now unfortunately, and I don't know how to fix this, my little Zoom people, hang in there because I'm gonna have to put them over on my math lab for just a second. And then I'll come back to you, I promise. Okay, so let's just look at some of these questions real quick on my math lab that you're gonna have to graph. You're gonna love this. Okay, seriously, this is good. Okay, so here's your graph. In this case, it wants you to graph -7 sine x. You're gonna click this to graph. Okay, here's your graphing tools because you've only ever graphed a line. This is your sine tool. How do you know that's your sine tool? Because you go up, middle, down, right? And also if you hover over it, it tells you. Okay, here's your cosine cup. If you hover over it, it tells you. Well, this is a sine. So click sine and then just click somewhere, anywhere at all, and it throws a sine graph on. Awesome. Okay, but we have to modify this a little. First of all, I have a negative out front. So what does that negative mean? Reflect. Boom. Reflect over the x. Okay. Then I have a 7 out front. What's the 7? The amplitude. Okay, so boom. There's my amplitude. If you kind of click on it somewhere, there it goes. All right, I don't have anything else. If I needed to change the period, I would go in here and change the period. If I needed to change the phase shift, I would do that. The vertical shift, I would do that. And there we go. Check answer. Perfect. So easy. Okay, now remember, it wants the domain. What's the domain of sine and cosine? Okay, but how am I going to put that in interval notation? Anybody remember? Yeah, that's your parenthesis. Good. Negative infinity, comma, positive infinity. Okay, there you go. Okay, then it's going to want the range. Your range is hard brackets. So it's just your up and your down. So we're going to go -7 to 7. And we need hard brackets. So here's -7 to 7. Perfect. It's going to want that for every problem, but then you're done. Easy enough, right? Okay, I already messed with that one. Let's see. Let's find a super hard one. That's got every living thing happening. That's not too bad. Oh, yeah, let's go back and talk about that. Okay. What in the world is happening here? Because this 1 minus, what? Sometimes my math lab, just because I think it hates me, I'm taking it personally. That's a vertical shift stuck in the front, okay? So your problem is actually -4 sine of 3x plus 1. Does that make sense?
Why they put it in the front?
I don't know. They hate children. So stick that in the back. It's a vertical shift, okay? Put that in the back. It's just super weird. So let's just graph him real quick while we're here. Okay, we know he's sine. We're going to get sine and click. There's our sine. Okay, the 1, we can go ahead and handle that. It's a vertical shift. You have to click this and scooch over 1. Okay, we did that. There's a minus. We're going to have a reflect. We did that. The 4 means amplitude. Boom, we did that. Okay. There's nothing, there are parentheses, but there's nothing added or subtracted in it. So do we have a phase shift? No, but we do have a b of 3. So 2 pi divided by 3. Now let me help you out here. If you, all you got to do is hit divided by 3. But if you lose pi on here and you're like, how do I put in a pi? There's no pi. You have to spell it out. Not the pie you eat. You got to spell out pi. So if I go pi, he turns into a pi. That'll save you some time. Divided by, what did we say? 3. There's our period. Woo. We save, we check, it said no, what the heck? Okay, let's see what we did wrong. Okay, amplitude of 4, we reflected. Oh, my vertical went minus, that's not right. Sometimes I think it moves stuff just because it wants me to look stupid. Okay, so anyway, you kind of get the gist of how to graph on here. It's fantastic. It's going to take you like all of 5 minutes and you're good to go. Okay. All right. Let me go and talk about section 6.5 real quick. And then we'll look at our calculators for a little bit. So I feel so bad I'm rushing through this. Are you guys okay with the graphing? You get it? So on my math lab, this is all you have to do. On your test, you're going to have 2 graphing problems. They're going to be pretty intense. I won't lie to you. We're going to practice Wednesday, but they're multiple choice. So I'm going to show you 4 pictures, A, B, C, D, and you just pick the graph that's right. So, you know, it's totally doable because we don't have time for you to do a whole trig test and then graph 2 super duper problems. And I'll show you how to even put those in your calculator and you can just match up the picture if you want to. Okay. But I don't want to cheat you out of any trig education. So is everybody okay with 6.4? Good. Okay. Let's talk about 6.5 then. All right. 6.5, little itty bitty thing. 6.5 is kind of one of those optional curriculum things we have. We'll have another optional one at the very last chapter. And so sometimes I don't even do it at all. And sometimes I throw it in there. And here we are throwing it in with 10 minutes left. So that's okay. It gives you an extra homework grade because there's only 6 questions and I'm going to give you the answer to those 6 right now. And then you can, you know, get 100. All right. So this is just graphing the other 4, which we don't require you to do at any point. Okay. So we have our good old equation here. So we know that with all 4 of these, the reason they're lumped together separately is because there are times when these 4, remember, are undefined, right? And they have vertical asymptotes. We looked at all of their graphs in section 6.3. So this little sentence here is your My Math Lab number 4. It's going to ask you how many, or I think it's a true or false. Most of you would just hit true, and then if it's wrong, you'd hit false. But I'm going to go ahead and tell you from the get-go, it's true. They have infinitely many vertical asymptotes because they all have places where they're undefined because they can all be 0 in the denominator. Okay? We know that these 2 are reciprocals of sine and cosine. So the steps to find them are exactly the same. No difference. Okay? Only difference would be domain and range. We'll look at that again in a minute because remember, these 2 are parabolas. Every time you have a hill with sine or cosine, their reciprocals have an up parabola. Every time you have a valley, those reciprocals have a down parabola. Every time you have an x-intercept for these 2, what do you have here? Asymptotes, right? And so that's where you get those graphs. Okay, the easiest way to graph these 2 is to graph these first. You actually cross out cosecant or secant and replace it with its reciprocal, graph that, then real lightly, then come back in and just draw parabolas and asymptotes. That's how you do it. There really isn't a way other than that to graph those guys. So that's kind of what we do, okay? Anytime there's a middle, you make an asymptote. Anytime there's an up, you make an up parabola. Anytime there's a down, you make a down parabola. Yeah, those dotted lines where they get really, really close, but they don't touch. They're undefined. Yeah. Okay, so this little sentence here, there's number 3. Yeah. Okay. So let's look at those 2 real quick. They're on the next page. Okay. So we mentioned that easiest way to draw cosecant is going to be draw your sine, but just do it real light, right? Then every time you cross the x-axis, put in an asymptote. Every hill, make an up parabola. Every valley, make a down parabola. And then you have your graph, okay? You'll do the same thing for secant. That's how you do it. So they just kind of show you that, for example, for sine, okay? For sine, you would have middle up, middle down. It would be Monday. Everywhere sine would have a middle, you replace it with an asymptote. Ups are ups, downs are downs. Same thing with cosine. So cosine is your dum. Middles change to asymptotes. Ups are up, downs are downs. Okay. All right. Another MyMathLab question. All right, is that cosecant is symmetric with respect to the origin. So remember, you can fold it on the y-axis and the x-axis. Secant is symmetric with respect to the y-axis. I can just fold it right in half because look what secant does. It splits the y-axis. That's why he's symmetric to that. So this is MyMathLab number 2. Okay. Talks more about your vertical asymptotes, your periods the same. We talked about domain and range a little bit when we had section 6.3, right? We talked about the fact that the domain here has to leave out, right, these asymptotes. We talked about the fact that the range still kind of stays right in here, but we exclude the area where we have sine or cosine. So it's just written a kind of strange way. All right, let's look at tan and cotan. Remember, those are the little groovy dudes, right? The little disco dudes that change their hands. Okay. All right, so remember their periods are smaller. Their periods are pi instead of 2 pi. So we just, again, exactly what we talked about in 6.3. There's really nothing else to say. To graph these, you put in your asymptotes, okay? And tangent starts at the origin and you just kind of curve them up this way, curve them down that way. You go to the next area, curve them up this way, curve them down that way. We don't really have any points that go along with it. It's more just an eyeball thing. That's why we don't even teach the graphing, okay? All right, so here's MyMathLab number 1. Is going to ask the symmetry in the vertical asymptotes of tangent. So tangent is symmetric to the origin. We talked about that in 6.3. The vertical asymptotes are odd multiples of pi over 2. Okay? Because x is 0 at those, so it makes it at pi over 2 and 3 pi over 2. And x is the denominator for tangent. So that's why those are vertical asymptotes. Okay, the y-intercept is 0. Tangent goes through the origin. This is MyMathLab number 5. Okay. And then MyMathLab number 6 actually asks you, I'm going to write the question, for what numbers x from negative 2 pi to positive 2 pi does the graph y equals tangent x have vertical asymptotes? Okay, that's MyMathLab number 6. Now you can certainly figure that out and it's also right there on the graph, but let's just talk about it and think about it because we haven't really, mentioned much on here. And then I think those are all the, let's see, let me make sure here. 1, 2, 3, 4. Yeah, those are the 6 homework questions right there. Okay, so it wants us to start not at the origin. It wants us to start at negative 2 pi. So if I continue out a little more, okay. I knew that was coming. I made another pencil out. Okay. So he's going to come on through and make a little groovy curve. Okay. And then this one is going to be an asymptote at negative 3 pi over 2. Here's negative 2 pi. He's going to come on over. Okay. And then this guy is going to be positive 2 pi. He's going to come on over like that. So really that's what the graph looks like from negative 2 pi to 2 pi. So it just wants you to list the vertical asymptotes in order. Okay, well, here's one, negative 3 pi over 2. Here's one, negative pi over 2. Here's one, pi over 2. And here's one, 3 pi over 2. Those are your answers. Okay, so that's where it's going to be undefined for that. Okay, so if you want, what I think I'll do, if you guys don't have any objection to it, maybe I won't make a video, maybe because this is already posted on there. Are you guys comfortable with just looking at my notes? If you wanted to know more information about it, you can email me so that you don't have to be the nerd that wants to know about tangent and cotangent. But I'm happy to record myself doing these graphs and letting you, kind of see how I do that, because some of them are kind of funky. All right, but you won't ever be asked to do that. Most of the time, hold on a minute, because most of the time you're just going to do it in your calculator anyway, and your calculator is going to do it for you. So what I want to show you, I have one minute. Okay, let's just look at this real quick, just so you can get an idea. We're going to practice again on Wednesday, okay? But let's just throw up a tangent graph on here real quick. Okay, so I'm going to put example 1 on here with a tangent graph. All right, so first thing I have to do is make sure I'm in radian mode, because you can only graph in radian mode. So I have to go to mode, I'm in radian, I'm good. Okay, then I'm going to go to y equals, okay, tan. Now, of course, we would have to enter in 1 divided by tan if I'm going to do cotangent, okay? And then I'm going to do, I'm going to put in an extra set of parentheses, pi divided by 7. Here's your x. You guys know he lives right here in this dude, okay? And then I'm going to graph, okay? And then I slowly start to get the weird dudes. Now your calculator gives the dude some big old hips, right? They are really curving it out. Okay, how do you know that you have the right window for this? Well, if you wanted to, okay, because we're finding jumps the same way we did here, our period's pi. So I would do pi divided by pi over 7. That reduces down to just 7. My jumps are 7 over 4. You can always go into your window and set these however you want them to be. My scalar could be 7, right? Because that's how many tick marks I want for each one. And then you could make it, to go out as far as you want to. And then every tick mark, you're going to see the little dude go right through, and it looks a whole lot like my graph that I did here. So on your test, okay, what you could do if you wanted is you could go through all this work we did where we come up with amplitude and period and jumps, and you draw it yourself and you match your picture to my picture, or you can just put right in here in radian mode, whatever it is, right? And we'll practice doing that. Then you go to window and you put X min, X max, whatever my window is, Y min, Y max, whatever my window is, and then you hit graph and you just match what's on your screen to A, B, C, or D. That's perfectly fine with me, because most people don't graph trig by hand. It's one of those things you really need to know how to do, so I taught it to you. But does anyone do that? No. Okay, so we're going to look at also how to do it in here, but MyMathLab makes it easy, your calculator's easy, and we'll review all that Wednesday. And if you want a little video, I'm happy to make it for you. So just email me, and I'm glad to do it, okay? But other than that, I will let you go now, and I will see you Wednesday. Let's see.